It's all the same quadratics that you dealt with in Algebra 1, you dealt with in Algebra 2. It's nothing different. You didn't deal with them very much in geometry, but it's okay. You spend enough time working with these guys in Algebra 2 to more than make up for it. So standard form. This is what standard form is. You got ax squared plus bx plus c. That's the universal way of writing the standard form for a quadratic function. What does a being positive do for the graph of that function? You may remember. Opens up. But we know the parabola shape. It would look something like that. Okay, and it would also indicate that that has a minimum. If a were less than 0, that means it's negative, and that would be the opposite, right? So it's going to open down. It looks something like that, and would have a maximum. That minimum or maximum occurs at what point? The vertex. Okay, so we have a vertex. Anybody remember how to find the vertex from a standard form parabola? Yeah, that gets us what part of it? That gives you the x value, negative b over 2a. That's also the same as the equation, x equals negative b over 2a is the equation for what? That thing, Yeah, man, a lot of them quadratics, exactly. Axis of symmetry. Remember x equals negative b over 2a was the equation for the axis of symmetry. Is that imaginary line that went straight down the middle of the quadratic? If I say something about axis of symmetry, oh, that's just the line that goes straight through there. But how do you find the y value for the vertex? Plug that in. So f of negative b over 2a. And depending on what a is, whether that vertex is the maximum or minimum, or is a maximum or minimum. So if a is positive, then that vertex is going to be a minimum. If a is negative, then that vertex is going to be a maximum. So we need to know those things out of that. We'll go ahead and write down that axis of symmetry stuff since we know it. How much it'll. Look at this. Things we know about parabolas already. Typically, under most normal circumstances, what's the domain? All real numbers. How do we write that?
X line, X, epsilon, symbol for all.
Okay, better way. Negative infinity to positive infinity. Interval notation is nice there. Domain is normally that. The range is dependent upon the vertex. And the a value, and I'll put a in quotes. So I have trouble writing in italics, so I'm just quote. Intercepts. If it's in standard form, what do we know the y-intercept is? C, yeah, that's exactly what it is. The y-intercept is going to be at 0, C. If it's in standard form, that's going to be the case. We can quickly get that. We could just as quickly get that by plugging 0 in for x, right? And it leaves C as the only thing left. So that's why that's the standard thing. There's standard form. All right, X-intercepts. Oh, How do we find x-intercepts? What are our options? Plug in what for y? Yeah, y is equal to 0. So we set the equation function equal to 0. And what are our options for solving that? We'll do an example here in just a minute, but what's one option for solving that? Factoring is an option. Does factoring always work? No, it doesn't always work, but it's nice when it does. The numbers are easy, you know, and factoring is a quick way to solve a quadratic. What if factoring doesn't work? Quadratic formula. Does it always work? Yes. And what is quadratic formula? Blah, 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 blah. I heard a lot of mumbling. Yeah. Sounds better when you sing it, but nobody did that.
I don't think Mac taught us this.
No, Mac didn't teach you to sing. My kids did. I sang to them. So, but anyway, so what is this this stuff under here called? That part underneath the square root, the b squared minus 4ac. What's the name of it? I'll give you the last letter.
I know it's the sickest game of hangman I've ever played.
And you think a different way.
It's just, you just want to say something. Nance.
We don't know.
Obviously.
Okay, see, you sure that
Discriminant.
I thought it started with I.
So do we know what discriminant is? Yes. No, I do, okay? Discriminant discriminates what kind of answers we could have and if we even have x-intercepts, okay? That's the whole point of the b squared minus 4ac was to tell us those things before we did all of this work of the quadratic formula for nothing, okay? Sometimes we didn't even have x-intercepts, but if we knew what b squared minus 4ac was, that told us. So if b squared minus 4ac is less than 0, that means it's what kind of number? If it's negative, right? And if we take the square root of a negative, that ends up giving us what kind of solutions? Imaginary, which means it's complex roots. Which complex roots, do they cross the x-axis? No, so that's no x-intercepts because they're complex. Meaning they have the imaginaries, the i's in there, okay? If b squared minus 4ac were equal to 0, how much? One x-intercept. Good job. One x-intercept. Where will that x-intercept be? At the vertex. Good, good. Absolutely. All right. And then the other scenario, if it's greater than 0. 2 x-intercepts. This only works if it's in standard form, though. So we've got to be careful of that. Okay. So let's start. Let's do an example of one that's in standard form. F of x is equal to x squared minus 7x plus 12. we're going to find, let's find all of those things. Let's find the axis of symmetry, since we'll have to find it anyway. Let's find the vertex. Let's find any intercepts we might have. And then we'll just go up here and do domain. All right. Can we tell the domain already? Yeah, what is it? All real numbers, negative infinity to positive infinity. We know that automatically because there's no red flags, there's not a square root in the problem, there's no x's in the denominator, so we automatically know that that's what's happening. Can we tell the range yet? Okay. Yeah, we know it's going to be in the positive direction because the A is 1, it's bigger than 0. Okay, good. So that we know that this one's going to open up like this because A is positive 1. Okay, we're not sure where the range is going to start, but we know it's going to go toward positive infinity. So let's find out where it goes. So to do that, we need to find the what? Vertex, and the vertex, in order to find it, we need to find the axis of symmetry. So let's do that first. X equals negative b, so positive 7 over 2 times a. That's 7 over 2. So the axis of symmetry is the equation x equals 7 over 2. And yay, it's a fraction. So that tells us wonderful things. Means we got to work a little bit. So how do we find the y value for the vertex? Plug that back in. So I'm going to go f of 7 over 2. Plug that in. So 7 over 2 squared minus 7 times 7 over 2 plus 12. 49 over 4 minus 49 over 2 plus 48 over 4. I'm going to change it to 2. I'm going to change it to 98 over 4. So that'd be 49 and 48 is 97. So positive 97 and negative 98 be negative 1 over 4. Is that right? Might with the calculator check me there. I just want to make sure. Negative 1/4. So there's our vertex. So we know because this thing opens up that what's the lowest value in the range? Negative 1/4. So the range is going to go from negative 1/4 up toward positive infinity. We know that because the graph opens up like that. Okay. Is that a bracket on the negative 1/4 or a parenthesis? Bracket. We know that that's equal to, that's where the vertex is. Okay. Intercepts. I like to do the y-intercept first because it's super easy. What is the y-intercept? Okay. Give me the ordered pair for that. 0 pair. Thank you. All right. X-intercepts. That's our y-intercept. It's an intercept. We're just calling it a y-intercept. You don't really have to tell it's y-intercept. How do we find our x-intercepts? What would be set that function equal to 0 and work it from there. So what would be a good way to work this one? Factoring. I think factoring is always a good shot when there's a 1 in front of x squared. A is 1. Factoring is real easy to check if it works. If a is something other than 1, maybe factoring is not the fastest way to go. But I think it's worth a shot here. So multiply to be 12, add to be negative 7. Negative 4, negative 3. Okay, so we found it pretty quick that it works. So because there's a 1 in front of x squared, that means the factoring is real quick. X minus 4, x minus 3. And then what do you do with each of those factors? Set them equal to 0. So x minus 4 equals 0, x minus 3 equals 0, x is 4, x is 3. So we have x-intercepts at 4, 0, and 3, 0. So we have 3 intercepts for this graph. We would have gotten the same x-intercepts had we used quadratic formula. It does the same thing. Okay? So, be aware that that is the same thing. How can we verify that all this stuff is happening? Look at the graph, because all this stuff that we found goes with a graph somewhere. So if I go to my calculator, hit y equals x squared minus 7x plus 12, and then hit graph, we see it crossing the x-axis at 3 and 4. That's promising. That means we probably did right. And then we think that this is 7 over 2, negative 1/4. It looks definitely like it's a negative something. It's small. So I can hit trace and just type in 7 over 2. And that y value there, negative 0.25, that's negative 1/4, right? So we found that vertex there. It opens up like we thought it should, that sort of thing. What do we know about that vertex? It is a what? Minimum or maximum? Minimum. So somewhere note that that is a minimum. Just be aware of those things. And we got the domain and range of that. So in standard form, all of those things. We did a lot of work with standard form in Algebra 2 and Algebra 1. So you should be very familiar with working with those. The next form would be Vertex Form. You may have worked with some, but probably not as much. Sometimes you will see this called shifted form, but it's vertex form when you're specifically talking about a parabola or a quadratic. Does that look familiar to anybody? Somewhat. We know that when we talked about transformations back in chapter 3, that this thing is the x squared function, and it's been shifted to the right h units and up k units, and it's got a vertical something depending on what a is there. It's going to be a stretch or a compression vertically because it's on the outside. So we know that's why they call it. You might hear it called shifted form, because it looks like the transformations that we did back in chapter 3. So sometimes you'll hear it called shifted form. For the most part, you'll hear me say vertex form just because that's what I'm used to saying. Okay. All right. So what does A do on this one? Anything different? It determines whether it opens up or down, right? Same way it did in standard form. So that is no different. A decides what direction we're going. A decides whether we have a maximum or a minimum. Always. Okay, when you're doing quadratic. So that A doesn't change. That is the same A that would be in the standard form for that. What does change is the amount of work you have to do to find the vertex and axis of symmetry. Very, very easy to do. Okay, so axis of symmetry just x equals h, whatever h is there. Your vertex, h comma k. Straight up, just easy. Now, the intercepts, not quite as easy. For the y-intercept, we can't just look at C and get the answer. We actually do have to do the work of plugging in 0 for x and evaluating it. Not that that's a ton of work, but it's what we have to do in order to find the y-intercept. X-intercepts, how did we find them in standard form? Set the problem equal to what? Set the problem equal to 0. We're going to do the same thing with these. The only difference is the method in which we're solving. Solving by square roots is the method that you would use, the quickest way to solve for the X-intercepts on a quadratic that's in vertex form. Okay. What do we know about the domain? Yeah, it hasn't changed. It's still quadratic. Negative infinity to positive infinity still. The range, because it's in vertex form, we automatically know the vertex. And in standard form, we had to find that vertex before we could discuss the range. Well, with vertex form, we already have the vertex. So we don't have to do any work to get there. So we could go straight and get the range here. And it's going to start at K. And if A is positive, it's going to go up to infinity. So if A is greater than 0. If A is less than 0, that means the parabola is going to open down. We're going to have a maximum. So it would be from negative infinity up to K. Depending on what, again, A decides the direction we're going, the maximum and minimum, and what direction we're going with the range as well. So you can get domain and range if it's in vertex form without doing any calculations as far as that goes. Right? Just look at A, and then K is going to be your value because that's the Y value of the vertex, just like it was in standard form. All right. Do what now? It's not quadratic because it'd cancel out that whole piece there. That would be when that happens. Good question. All right, let's look at an example. G of X is equal to 2x minus 3 squared plus 4. We'll go ahead and do domain and range up here. Domain is a given. It's negative infinity to positive infinity. Nothing changing about that unless it's a word problem and we got some context. That knows the x-axis is time. Negative time is pretty tough to come up with. Figure it out, but no. We'll make millions together. Maybe even billions. We'll make a lot more than that. We got time travel figured out. I know exactly what I'm doing. Yeah. All right. So axis of symmetry. This should be fairly quick. X equals not negative 3, positive 3. It's always going to be the opposite of whatever sign is in there. So if it's a minus 3 in here, it's going to be a positive 3 out there. If it were a plus 3 on the inside, it's the opposite. Goes back to that original form, has the minus sign in there. And remember when we were doing translations and transformations in chapter 3, whatever happened on the inside, it was the opposite. So a minus moved to the right instead of to the left. Same idea here. Okay, axis of symmetry is 3, so the vertex would be 3, 4. Yeah, straight up. You don't have to do any work to get there. Okay. Let's get our intercepts. So Y-intercept. Did that first on the first example. We'll do that first here. How do we find the Y-intercept? Plug in 0 for x. So f of 0. So 2 parentheses 0 minus 3 squared plus 4. 2 times 9 plus 4. 22. 0, 22 as an intercept. But X-intercepts. Set the whole thing equal to 0. And get X by itself. So we're going to solve by square roots. If we're in vertex form to begin with, that's the easiest way to get X-intercepts. for that. You know, you could, if you wanted to do quadratic formula, if you're one of those folks that just I like quadratic formula because it's the same every time and it works well, you can do that, but you've got to multiply all this stuff out and simplify before you start. Okay, so you would have to say x plus or x minus 3 times x minus 3, get x squared minus 6x plus 9, and then distribute the 2, and then add 4 at the end there. So it can be done, but it's a longer process to do it that way. So square roots is the quickest method. So we'd subtract 4. And then divide by 2. So we have x minus 3 squared is equal to negative 2. The next step would be taking the square root. And the thing you've got to remember when you're doing square roots is a plus or minus goes in front of that. But we're taking the square root of a negative 2. So what do we know about that? It's complex, right? So it's plus or minus I radical 2. What we know from there is that, yes, it has zeros or roots, but they don't exist on the coordinate plane. It should not cross the x-axis because imaginary or complex x-intercepts don't show up. Okay, we could solve that and get x equals 3 plus or minus I radical 2. That gets us, you know, that's the solutions, but those are not x-intercepts. So there's actually no x-intercepts for this one. And when we verify that by the graph, we'll see it doesn't cross the x-axis. With a graph, y equals 2 parentheses x minus 3 close parentheses squared and then plus 4. We see that parabola there. We don't see the y-intercept here. We know it's up there at 0.22.
My calculator says the error invalid dimension.
Okay, did you turn? You made a, you must have turned
Thank you.
Yeah. All right. So we get that graph. We see it doesn't cross the x-axis. We know that it opens up. So we have a minimum on our vertex. So we'd note that somewhere. Minimum on our vertex. Okay. So vertex form. Seen it before. I mean, I has done as much with it as we have standard form. Last form, intercept form. In Algebra 2, we call this factored form most of the time. When I said factored form, you knew that factoring was the game that was done. With quadratics, if it's in intercept form, it's already factored for you. You don't have to do any of that work. So it looks something like this. Oops, x minus m and x minus n. Okay. As far as there are some shortcuts that exist for finding the vertex and the axis of symmetry for this, but I don't think memorizing shortcuts for this sort of stuff is really helpful. So my suggestion is multiply the thing out into standard form and then do all the rules for standard form. So you only have to know one set of rules for standard form. You don't have to know all these shortcuts with changing the sign and dividing a certain way with our factors to get those things. So my notes for intercept form are multiply the standard form times vertex axis. Okay. Now for zeros though, since it's already factored, to find the X-intercepts, you just set the thing equal to 0 and then set each factor equal to 0 and get it. So it's already factored for you. So the multiplying it out, you know, don't go through all the hard work of doing quadratic formula or refactoring it, because it's already factored for you. So you just set each factor equal to 0, and that gets you your X-intercepts out of that. To get a Y-intercept, really doesn't matter which form you plug that in. If you're in intercept form, plug a 0 in for X to get the Y-intercept. No matter what form you're in, you plug a 0 in for X and get the Y-intercept. So, but to find the vertex or the axis of symmetry, my suggestion is just multiply it out to standard form and then work that out. If you want to know the shortcut, it's to take the root here and the root here and find the midpoint between those two, and that gets you the X value of the vertex or the axis of symmetry, and then plug that back in, and it gets you the Y value that goes with it. So it's not hard, but if you're gonna have to add them together and divide by 2 or whatever you got to do to find the midpoint of it, might as well just have it in standard form and get all those things, because then you get the Y-intercept for free if it's in standard form, instead of having to plug in 0 and then work it out. So you get a lot of things for free in standard form that you don't get there. So let's look at an example of one that's in intercept form. And let's say h of x is equal to -6, x plus 7, x minus 8. Okay. So domain, rank, all the same things we're going to find. Domain, we know, is negative infinity, positive infinity. Range, we got to find the vertex first. So we'll have to do that to find those. So let's do that work. In order to find the vertex, we're going to have to multiply this out. So when we multiply this out, you know, it's distributed property. You're distributing x plus 7 to x minus 8. So x times x times -8. Then distribute the 7. So 7x -56. Simplify that. X squared minus x minus 56. And then distribute the -6. -6x squared plus 6x plus 6 times 50 is 336. So there's our standard form now. So we took something that was in intercept form and put it into standard form out of that. So that gets us a few things for free. It gets us the Y-intercept for free. It's at 0, 336. Because remember, if it's in standard form, the Y-intercept's always whatever C is. So we get that for free. And then we need to find the axis and then the vertex as a result of that. Axis of symmetry, so we take -b over 2a, -6 over 2 times -6, which would be 1/2. Positive because it's negative divided by negative, so we're plugging in a 1/2 into our problem to work it out. -6 1/2 squared plus 6 times 1/2 plus 336. That's going to be 1/2 squared is a fourth. A fourth times -6 would be 3 over 2 negative plus 339, because 1/2 of 6 is 3 plus 336, 339. And then work that out. 1.5 taken away from that, so it'll be 337.5. 337 times 2, 674 plus 1. 675 over 2, is that right? Okay, awesome. By all means, you can use a calculator. I like challenging myself to not use one. Okay, so we have the vertex. Is that vertex a maximum or a minimum? Why is it a maximum? That's right. A is negative, so we know this thing opens like that. Okay. Now we've got the y-intercept. It's at 0, 336. Let's find the x-intercept or intercepts. And because I already have it in factored form at the beginning, that's how I'm going to find my x-intercepts because it's so much quicker and easier. I just set -6, x plus 7, x minus 8 equal to 0. Well, this is mathematically what happens with the -6. It goes away. So we get x plus 7 and x minus 8 equals 0. And set those equal to 0, get x is -7, x is +8. So we have intercepts at -7, 0, and 8, 0. We can go back and get our range now. Our range, since we know this thing opens down, is going to start at -infinity and go up to the y value of the vertex. 675 over 2. Oops, wrong notation there. Should be a bracket on that. It's included. All right. Okay, so last thing in this section is writing an equation. Writing an equation given certain info. Okay, so here's the things that they can give you. They can give you 3 random points and say it's on a quadratic. We're not going to do that in this section. There's a later method we'll talk about later on in chapter 12, I think, that we'll do that sort of stuff with. What you're going to get things in this section from are they're going to give you intercepts, 2 x-intercepts, and 1 other point. If they give you 2 x-intercepts and 1 other point, what form do you think you start with? Intercept form. Okay, so if they gave you 2 x-intercepts, say like 0, 5, 0, -3, and then 0, 7. Not 0, 5. I did those backwards. 5, 0, -3, 0, and then 0, 7. So we would start our function A, and then which ones of those are x-intercepts? The first 2. So what's the factor that goes with 5 as an x-intercept? X minus 5. What's the factor that goes with -3? X plus 3. But we don't know what A is. This is where the other point comes in. 0 is what? On this point. X or Y? X. 7 is, oh, we could plug those in. Now the only variable left in my problem is what? A. And that's how we're going to find A, is we're going to use that third order pair that they gave us. Okay, so work that out. -5 times +3 is -15. So we have -15A is equal to 7. Divide by -15. A is -7 over 15. So our final function, f of x, is -7 over 15, x minus 5, x plus 3. That's it in intercept form. If I ask for it in standard form, what do? Just multiply it out. Okay? I'm not going to ask you to put it into vertex form from there. So you'll get intercepts and another point and be able to put it in either intercept form or standard form. So it's just multiplying it out if that's the case. Another scenario, that's example D. Example E would be same idea, write the equation, but you're given a vertex of, say 2, -5 through 0, 8. They gave you a vertex and another point. That other point happens to be a y-intercept, but it doesn't necessarily have to be a y-intercept. It just is in this case. It could be any other point. Important thing is they gave you a vertex. So what form do you start with? Vertex form. Okay. So your function should start out looking like this: a parentheses x minus 2 squared plus 5. Not plus 5, minus. Now, how do we use 0, 8 to fix this problem? Plug it in for x and y. 8 is y. We don't know what a is, but we know x would be 0. If 8 equals 4a minus 5. We solve that equation. (13/4) is equal to a. So our function in vertex form looks like that. If I wanted it in standard form, multiply it out. Square the x minus 2, then distribute the 13/4, and simplify. Okay? Those are the things that we need to be able to do. Okay? The other thing, if they give you 3 random points, uses systems of equations, and we don't really talk about doing systems of equations until I think chapter 12, I think is the right number, out of that, and we'll revisit building quadratics from 3 random points when we get there. So, all right. Problems that you'll need to work on, page 3, 11 through 87. Skip 51 and 52, because those are the ones where they give you 3 random points. The rest of them, they give you something like what we talked about there. So that gets you section 4.3. That is going to be the last section that we'll cover in chapter 4. So we're quickly approaching the chapter 4 exam. See, tomorrow's work day, quiz on Thursday, review, and probably, if we're here, test Friday. So over chapter 4. So you guys have a great day. I'll see you tomorrow. Or